We want to solve the inhomogeneous equation r dq dt plus q over c equals v with initial condition q equals 0 at t equals 0. This is an equation which corresponds to a given circuit, and we're going to use the method of lucky guesses. So our first step is to solve the homogeneous equation, and the homogeneous equation is r dq dt plus q over c equals 0. This is a separable equation. We have that dq over q is minus dt over rc. We integrate each side, and we get that the natural logarithm of q is minus t over rc plus a constant of integration that we're going to call a because c is already being used. We take the exponent of both sides to undo the logarithm, and we end up with q equals e to the minus t over rc plus a, and by making use of a different constant I'm going to call that b e to the minus t over rc. In the lucky guess method, we try to guess what the solution to the inhomogeneous equation is going to be. So we start off with the solution to the homogeneous equation. B is e to the minus t on rc, and then we add on our guess for the extra bit we need to solve the inhomogeneous equation. Because the right hand side of our equation is a constant, we're going to guess that the extra bit we need to solve the inhomogeneous equation is going to be a constant I'm going to call alpha. We need to substitute that into our original equation. So for this we also need dq dt. dq dt is minus b on rc e to the minus t on rc, with the alpha giving a derivative of 0. So now we take our solution, now we take our inhomogeneous equation and substitute in our guess. So that was r dq dt plus q on c equals v. So substituting in our expressions for q and dq dt, we get minus r b on rc e to the minus t on rc plus b on c e to the minus t on rc plus alpha over c equals v. In the first term we can cancel the r's, and now we see we can cancel the first two terms. So that leaves us with alpha over c equals v, or alpha equals cv, which means our general solution to the inhomogeneous equation is q equals b e to the minus t over rc plus alpha, which is cv. To make further progress, we need to substitute in the initial condition, which is at q equals 0, at t equals 0, and when we substitute that in, we get that 0 equals b plus cv, or b is minus cv. So our full solution to both the differential equation and the initial condition is that q is CV 1 minus e to the minus t on RC.